Today is going to be 103-1, and we're going to take a look at solving logarithmic equations. And so that's today's objective. We're going to solve logarithmic equations. Now, in solving a log equation, we will use the concept that an exponential function is its inverse. So remember, exponential functions, logarithmic functions, they are inverses of each other. Now, a few steps to help us solve these logarithmic equations. The first thing maybe we should look at, is there any way for us to isolate the logarithmic function? Meaning if I have a number in front of it, or if I'm adding some sort of number to it, we may have to take steps to manipulate the equation to where our log is now isolated. Then, step 2, it kind of diverges into two parts. Sometimes we have a log with the same base on both sides. Now, if we're able to do that, we could, change that into exponential form, and if we change that into an exponential form, the logs generally cancel out, and we can equate the equation from there. Part B, sometimes we may have to manipulate and rewrite the log purely as an exponential equation, and then be able to go from there. Because to count or to manipulate in terms of a log is much more difficult for us to be able to evaluate or count in terms of an exponent. Now we have to remember the domain of logarithms as it pertains to our functions. Our domain of a natural log, or just a regular old logarithm, is from 0 to infinity. Remember, that means can't be 0 and it can't be negative. If it's either 0 or if it's either negative, inside of a logarithm, whatever solution I may find, it won't work. So because my natural domain is not from 0 to infinity, every single log equation, you have to check your answer to make sure that the answer exists within your domain. So this first one, solve the equation. Well, if I notice here, my log is isolated here, right? There's no number being multiplied, there's nothing being added, nothing multiplied, nothing being added. So my logarithm has been isolated. Now, because both sides have the same base 17, I can actually write this as, or convert this if I wanted to, into exponential. If I take base 117 to both sides, converting that into the exponential, I understand that verbiage may not necessarily be, it's just there to help us identify that the fact that it's the inverse. But by converting that into exponential form, the logs completely cancel out. And so I get 1 minus 3x equals x squared minus 3. Well, this is a quadratic equation. The way that we solve quadratic equations is by trying to factor quadratic formula. So let's set it equal to 0. So that means I'm going to add the 3x, subtract the 1. And so I get x squared plus 3x minus 4. And so this will actually factor into x plus 4 and x minus 1. And so x equals negative 4 and positive 1. And so these are solutions to whatever has been expressed here. But now we have to be a little careful, because we have a domain with our logarithms, right? Their natural domain says that it can't be negative and it can't be a 0 inside of our log. So I actually have to test each of these values. And I'm looking for, do I get a negative or do I get a 0 inside of my logarithm? Because if I get those, then clearly it's not within my domain. And so if I plug in negative 4, if you notice on this first one, I get log base 117 of 1 minus 3 times negative 4. That gives me a positive 13 inside of my logarithm. So I get log base 117. Does that equal log base 117? Now if I do that to the other side, that's going to give me 16 minus 3, which is also 13. So negative 4 works. But if I plug in 1, if you notice, I get log base 117 equals negative 2, or log base 117 and negative 2, and I get the same thing on the other side. Now, those both equal, right? I mean, clearly, you're just looking at it, they're exactly the same, but this contradicts my domain. I can't have a negative. So because I can't have a negative inside for my logarithm, we have to exclude that value from my solution set. 1 cannot be one of my solutions, and so -4 is my only solution here. So the first thing that I did is I made sure that my logs are isolated, and they were. And then essentially part 2, what I did is I converted it into that exponential equation. In the process of converting it, the logs happened to cancel out, and so then I was just able to equate what was inside of the log, which is represented in part A. The next one, isolate the log function. Well, if you notice, it's not by itself. I have this 2 and there's a negative in front of that log. So I need to take steps to be able to isolate it. So I'm going to subtract 2 on both sides. So I get -ln of x minus 3 equals -1. And then dividing by a negative, I get ln of x minus 3 equals +1. So it's been isolated. So now, because I don't have logs on both sides, I can't do part A and convert that into exponential, but part B, rewrite the log as an exponential equation. So to do that, I just take base e to both sides. And so I'm going to get x minus 3 equals e. E is e to the first. Add 3 to both sides. And so I get x equals e plus 3. So now I need to go through and I need to check my answer. So we got to plug this back in. So if I get 2 minus ln of e plus 3 minus 3, does that equal 1? Well, the 3's cancel out. Ln e is just 1. 1 equals 1. So it does work. So that is one of my solutions. Now this next one here. Isolate the logarithmic function. Well, I have 2 logs. I can't really get one by itself. What if I were to bring this log to this side? I would get log base 6 of x plus 4 equals 1 minus log base 6 of 3 minus x. Well, I still have this 1. What if I move the 1 over here? Well, that doesn't help me at all. So I can't necessarily isolate a log just yet. So we have to think a little differently. And we're going to have to go to the properties of logs to help us now. If you remember, one of the properties of logs says that if this is if this is addition, that means I can multiply what's inside the logs together and combine it into one log. Now, we have to make sure that those are the same. Now, they are both base 6, so I can combine these into one logarithm and I multiply what's inside the logs. So x plus 4 times 3 minus x, and that equals 1. So now my log has been isolated. There's only one log. There's nothing being added to it. There's nothing being multiplied to it. And so now I need to rewrite, we'll do part B here, rewrite the log as an exponential equation. So take base 6 to both sides. And so I'm going to get x plus 4 times 3 minus x, and that equals 6. Multiply everything out. So I'm going to get 3x negative x squared plus 12 minus 4x. And so I get negative x squared minus x plus 12 equals 6. Bring that to that side. I get negative x minus x plus 6 equals 0. Multiply everything by a negative. I'm going to move that over to here. So I get x squared plus x minus 6 equals 0. So now factoring this, right, it's a quadratic equation, so I can try and factor in it. That's going to give me x, looks like plus 3, and x minus 2. So my two values would be -3 and +2. So now checking to see if they work. Well, if I plug in the -3, I get -3 plus 4. Well, that's positive inside my log. 3 minus -3, that's also a positive inside my log. So it looks like that doesn't contradict my domain. So that one works. If I plug in 2 plus 4 is positive inside of my log, so we're good there. 3 minus 2, that's also positive inside of my logarithm. So it looks like this one also works. So this is also a solution. So both of those are a solution to my log. Next one. So isolating my logarithmic function. Now I have logs on both sides here. They're both same base 7. So to isolate it, I probably, because I can't do anything with this 1 right now, so maybe bring this to that side. So I'm going to get log base 7 of 1 minus 2x plus log base 7 of 3 minus x, and this equals 1. So now same idea here. I can go through now, and because this is plus, that we're adding these, I combine it into one logarithm, multiplying. So I'm going to get log base 7 of 1 minus 2x and 3 minus x. That equals 1. Take base 7 to both sides, so I get 1 minus 2x and 3 minus x, and that equals 7. Multiplying all of that through, you get 3 minus x minus 6x plus 2x squared. Combining like terms, I get 2x squared minus 7x plus 3 equals 7. Minus 7 on both sides because it's a quadratic equation. So I'm going to get 2x squared minus 7x. It looks like minus 4. So now we got to figure out how to factor this. So if I multiply a times c together, I get negative 8. The factors of negative 8 looks like negative 8 and positive 1. So I'm going to break out my middle term. So I get 2x squared, say minus 8x plus 1x minus 4. Factor by grouping, 2x, and I get x minus 4, and then 1, and I get x minus 4. And so now I'm going to get x minus 4 and 2x plus 1. So that means x equals 4 and negative 1/2. So now I have to test. If I plug in positive 4 back into my function, I get 1 minus 8. That gives me negative 7. I can't have a negative inside of my log, so that it's excluded from my domain. If I plug in this negative 1/2, okay, 3 minus negative 1/2, that's positive. 1 minus 2 times negative 1/2, that's also positive because negative negative, that'll be plus 1, so I get log of 2. So this one is a working solution because it doesn't contradict my domain. Part 5 here, solve the following equations. So once again, I have logs on both sides, so maybe I should bring that log to that side. So that means I'm going to get log base 2 of x plus 3 minus log base 2 of 6 minus x. And this is going to equal 3. Now we learned that when we're subtracting log, so because this is minus, that means this part of my logarithm is going to go into the denominator. So I can combine this into one logarithm. The x plus 3 is on top, and the 6 minus x is on the bottom. And that's going to equal 3. So now converting that into an exponential equation, you take base 2 to both sides. And so I get x plus 3 over 6 minus x. That equals 2 to the third is 8. Get x's out of the denominator. And I get x plus 3 equals 48 minus 8x. Combine like terms, so bring that over there. We get 9x plus 3 equals 48. Minus 3 on both sides, I get 9x equals 45. X equals 5. So now I need to plug it back in to make sure that it's going to work out. If I plug 5 back in, I get log base 2 of 8. And then this will become 1, so log base 2 of 1. They're both positive inside there, so that's going to be a working solution. Now for this next one, it is a little bit more complicated, and the reason why it's a little bit more complicated is look at my bases. Log base 4 and log base 2. Yikes. right? That does make it a little bit more difficult for us because they are different bases. So I have to use the change of base formula to help me and convert this into a correct entity. So one of the things that I'm going to have to do first is turn this, probably raise these powers. So I'm going to get 1 plus log base 4 of x plus 1 squared. And this is going to equal log base 2 of x squared. So we did that first. Now I need to change this into base 2. So I get 1 plus, now I'm going to get log base 2 of x plus 1 squared over log base 2 of 4. Now remember, when we use the change of base formula there, that's essentially what ends up happening is the change of base formula says, I'll just write it out for you guys, log base a of b equals log base c, so I choose whatever base that I want to turn it into, of b over log base c of a. And so I wanted c to be base 2, so there was my b and there was my a. Well, log base 2 of 4, this right here, that simplifies into 2. That's the same as 2. So right now I have 1 plus 1/2 log base 2 of x plus 1 squared. What if I raise that as a power now? So that's going to give me 1 plus log base 2, the 1/2 times the 2. That just gives me x plus 1. And this is going to equal log base 2 of x squared. So now that they're all the same bases, once again I can isolate my log function here. So I'll maybe bring that on this side. So I'm going to get, just so I can separate it a little better, I get 1 equals log base 2 of x squared minus log base 2 of x plus 1. So now I can combine those into one logarithm. 1 equals log base 2 of x squared over x plus 1. So now I can change that and rewrite that into an exponential equation. Take base 2 to both sides. 2 equals x squared over x plus 1. Multiply both sides by x plus 1 because we have to get x out of the denominator. So I get 2x plus 2 equals x squared. Bring everything to one side. 0 equals x squared minus 2x minus 2. Well, does that even factor? Doesn't look like it. So we may have to use the quadratic formula here. Let's see. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to get 2 plus or minus the square root of negative 2 squared minus 4 times my a times my c all over 2 times a. So that's going to give me 2 plus or minus the square root of 4 plus 8 over 2. I'm running out of room. I'm going to continue here. I'll do it in purple. So I get 2 plus or minus the square root of 12 over 2, which is 2 plus or minus 2 root 3 over 2, because I can break the root 12 into root 4 and root 3. And then all the 2's cancel out there, so I get 1 plus or minus root 3. But now we got to test it. Now if I plug in the 1 plus root 3, it's going to work. Because root 3 is bigger than 1. If I plug in 1 plus root 3, I get positive. 1 plus root 3, I get positive. The 1 minus root 3 is the issue, because that's a negative number. If I plug in 1 minus root 3, that won't work. 1 minus root 3, that it does work in that one, but it doesn't work in the first one that I showed. So my only answer that I'm going to box here is 1 plus root 3. That right there That's the golden value. That's what works. Now, in conclusion, what concepts were discussed today? We solved log equations, and it's a little different. Some of it's a little conceptual, but just know that we have to use our properties of logarithms to kind of combine logs together if needed. And most of it we turned into an exponential form equation because it's much easier to visualize and count in those terms. And then what did we have to do to the equation to solve a log, and are there natural domain restrictions to log equations? So I want you guys to go ahead and reply to those two questions there in the comments. And as usual, if you have any other questions, please leave them in the comments.